Hello, as we saw in the last video, we generate the IP plan of our network thanks to IP address library. Today we will recreate our backbone diagram with another library which is Networkx. So first, let's modify our previous for loop. At the beginning we add new variables, its edge, which is an empty list, and edge labels, which is a dict. Now at the end, we announce a new variable, which is edge. It's a tuple and it takes the couple host and its neighbor. As I said, it's a tuple, which is a kind of Python data. And after that, we append the edge to my list. So it's append is a built-in function that allows me to add a new item to my list. Then we update my edge labels. So edge labels of edge equal to my interconnection network. I execute the code, and to check we can print edges labels. So please note that the structure is depend on Networkx documentation. So you can take a look on web page of Networkx to discover more functions. So here we can see in the result, I have a couple of routers, and as a label we found the interconnection network. Now to draw the diagram, we will use Networkx. For this reason, we import Networkx library as NX. Then we announce a graph variable. It's a graph. Then we have to create nodes as a list. So it's a list, and here we can use, as we saw previously, the host's loopback dict. So as a key we can find router's name. So here simply we can put list of host's loopback dicts dot keys. Okay. Now we add nodes and edges to my graph. So I use add nodes from, and I put my nodes list. I do the same for edges. So graph, and I use add edges from edges. Here I announce the position. So here I will put nx.spring layout, and I can use any other layout, shell or circular. It takes my graph, and here there is an option called seed equal to 7. I can put other number, and now I can draw my diagram. So I use draw function. It takes a graph, the option with labels equal to true to put my router's name on the node. I will give it the position and node's size. So here I can suggest 700. Okay, so I can run the code now. Okay, so it seems like I have a problem. Okay, so here I have to delete the S from node size. Okay, so here as you can see I have a diagram. I have my 4 routers interconnected. So I will add links labels. So I will use draw Networkx edge labels. Draw Networkx edge labels. So I give it my graph, the position, edge labels, and there is an option called label position. I can put 0.5 and I run my code. So I have a problem. We have to remove the S from edges. Okay, so now I can see my four routers, and now I can see also the interconnection network on the link. It's good. Okay, so now let's move to another kind of test. So here, imagine that we have to send some packets from router 1 to router 3, and if ECMP, the equal cost multipath, is enabled, our packet will go through two paths. The first one, it will go through router 2, and the second will go through router 4. Okay, so let's check if my graph will give me the same result. And to do that, I will look for paths. So I code for path in nx dot all shortest paths. I will look for all shortest paths, and this function uses Dijkstra algorithms, which is in line with OSPF. So here I will put source is router 1, target it will be router 3, and finally I will print the path just to see the result. Okay, I run it, and exactly here I can find two paths. So the first one goes through router 2 and the second goes through router 4. So why? So here I will print the graph of router 1 just to see the topology. What can I use to break this tie? So here for router 1 I found router 2 and an empty field or an empty weight. So to change it, I will put router 1 to router 2, and here I will choose the weight. I will call it cost, and it will take 10 as a value. I will do the same between router 1 and router 4, but here the cost will be 30. Okay, now I will take my loop and I will execute it, but before that I will add at the end weight equal to cost. So I will told the Networkx to use cost as a tie break to choose path. And here, as you can see, I found only one path, which is the path that